Hi, today our discussion topic is very important now. That is global climate models. Is there any idea of how do scientists predict what the climate will look like in 50 years? They don't guess then, they simulate. Global climate models divide the entire planet into a three-dimensional grid and run the laws of physics forward in time, hour by hour, decade by decade. In this video, we'll break down exactly how these models work, what they simulate, and why they matter. But next, what GCMs are. A GCM full form is Global Climate Model, which is a mathematical representation of Earth's climate system. It divides the planet into a grid of cells as horizontally and vertically through the atmosphere and calculates how energy, moisture, and momentum move between them. At its core, it's the laws of physics translated into code, simulating the planet's climate one time step at a time. Then, what they model these models simulate every major piece of the climate system. The atmosphere brings temperature, wind, and precipitation. The ocean tracks currents, heat exchange, and deep circulation. The land surface accounts for soil moisture and vegetation. And the cryosphere, sea ice, glacier, and snow, captures powerful feedback loops like melting ice, reducing reflectivity and accelerating warming. Next, we will see that how they work at every grid point. Physical equations for fluid dynamics, thermodynamics, and radiation are solved simultaneously, then step forward in time, sometimes for centuries. But processes smaller than a single grid cell, like individual clouds, can't be directly resolved. Instead, they're estimated through parameterization, simplified approximations that keep the simulation computationally possible. Now move on to types of climate models. Not all climate models are the same. Energy balance models are the simplest, tracking only global energy in and out. GCM simulate full 3D atmospheric or ocean circulation. AGCMs couple the atmosphere and ocean together. And Earth system models go furthest, adding the carbon cycle, ice sheets, and vegetation dynamics for the most complete picture available. Or then note down the key uses and applications. These models aren't just academic exercises, they project future warming under different emission scenarios, helping shape international climate policy. They support attribution studies, determining whether a specific heat wave or drought was made more likely by human driven change. And shorter term versions feed directly into seasonal forecasting, guiding agriculture and water resource planning, notify the major modeling centers and CMIP. Climate modeling is a global effort. Institutions like NASA's GSS, Norway's GDL, the UK Met Office, Germany's Max Planck Institute, and NCR in the US each run their own models. Through the Coupled Model Intercomparison Project or CMI, dozens of these models are compared side by side, giving the IPCC a broader, more reliable range of projections. To finally see the limitations, no single model is perfect. Resolution limits, parameterization, and the chaotic nature of climate all introduce uncertainty. That's why scientists run ensembles of many simulations across many models rather than trusting just one. The result isn't a single forecast, but a range of plausible futures, giving us the clearest picture yet of the planet we're shaping. Thanks for watching.